Hello students. So today we will learn exponential limits. Okay. So there are some standard limits. Limit is x tends to 0, a raised to x minus 1 upon x is log. Okay. So if you have, say, suppose example, limit is x tends to 0, 2 raised to x minus 1 upon x, then the answer is log 2. Okay. Take another example. 5 raised to 2x minus 1 upon x. Okay. Now you have to make this raised to thing equal. Okay. So we need here 2. So I will divide and multiply by 2. So this whole thing becomes log 5 into 2 or 2 log 5. Okay. Limit is x tends to 0, 2 raised to x minus 1 upon 3 raised to x minus 1. So here we can divide and multiply by x upon x, and that multiplied x will come in the denominator of this. Okay, here limit is there. Limit is x tends to 0. Okay, so this thing becomes log 2 and this is log 3. Okay, so you can write this as limit as x tends to 0, some a raised to x minus 1 upon b raised to x minus 1 will get log a upon log b. Okay. Um, Limit as x tends to 0, 4 raised to x minus 3 raised to x upon x. Okay. Now we want this in the form a raised to x minus 1. Correct. So we have to add and subtract 1. So I'll add, subtract 1 from here. Okay. Minus. So I'm adding also 1. And this minus 3 raised to x is there. Okay. So we have to adjust this. So if I take this minus outside, okay, then this will be 3 raised to x minus 1. Correct. So we'll get 4 raised to x minus 1 upon x minus 3 raised to x minus 1 upon x. So using algebra of limits, a minus b is limit a minus limit b. So this becomes your log 4 minus log 3. So log a minus log b is log a upon b. So here also you can use the standard formula, that is if you have, say, limit x tends to 0, a raised to x minus b raised to x upon x, then you can directly write this as log of a upon b. Okay. Next question. Limit x tends to 0, e raised to 3x minus 1 upon 3x. Okay. Same you have to apply here. So I have to wait. This is given like this. Okay. So we have to make it 3. So divide and multiply by 3. Okay. So this is going to become log e into 3. Okay, and log e is 1. So you can write this as 3. So whenever you have, say, this limit as x tends to 0, e raised to x minus 1 upon x, answer is 1. Okay, this is also a standard result. Okay. So we have to evaluate this. Okay, here 3 raised to minus x is given. So we have to remove this. How to remove it? We can write it in the denominator. 1 upon 3 raised to x. Okay. So cross multiplying, you'll get 3 raised to x square. So this is 3 raised to x square, that is 2x, correct? Plus 1 minus 2 times 3 raised to x upon 3 raised to x into x square. Okay. So if you look at this term, you will understand that this is a minus b the whole square. Correct? So if I take this as 3 raised to x minus 1 the whole square, then you will get this as 3 raised to x the whole square minus 2 into 3 raised to x plus 1. Same term it is. So we can write this as limit as x tends to 0, 3 raised to x minus 1 the whole square. Okay. Upon, here it is 3 raised to x into x square. Okay. So this thing 3 raised to x minus 1 and divided by x square becomes log 3 square. Okay. Log 3 square divided by 3 raised to x. So I have to take limit. So this will be 3 raised to 0, which is 1. So the final answer is log 3 square. Okay. Next question, limit as x tends to 0, 12 raised to x minus 4 raised to x minus 3 raised to x plus 1 upon x square. So here we can split this 12 into 4 threes are, correct? So this is a into b raised to x. So a raised to x into b raised to x. So 4 raised to x into 3 raised to x, correct? So we can take common here 4 raised to x. So you'll get inside 3 raised to x minus 1 minus I am taking common from this term. So 3 raised to x becomes positive and this becomes negative. Now again taking 3 raised to x minus 1 common. Okay, this x square, I'll take one x here and another, this is for 4 raised to x minus 1. So then taking limits, you will get here log 3 into log 4. Okay. There is one more standard result, that is limit as x tends to 0 log 1 plus kx upon x, or the same thing we can write it as like this, raised to 1 by x, correct? So it becomes log e raised to k, the answer is k. So whatever your k is, that will be your answer. Okay. We'll do some more limits problems, okay, later on. Next we'll see derivative. Okay. So graphically, derivative is nothing but if you have a curve, say, okay. So if you draw a tangent to that curve, so the slope of this tangent is the derivative, that is change in x with respect to change in y. Slope is dy by dx. Change in y with respect to change in x. This is derivative. Okay. This is our geometrical interpretation. Okay. So there is a principle, that is first principle of derivative. Okay, which we will be using to find the derivatives. So first principle of derivative. Okay. So derivative is given by f dash of x equal to limit as h tends to 0 f of x plus h minus f of x upon h. So we are asked to find the derivative of a function using first principle of derivative. So definition is that wherever the limit exists is defined to be the derivative of f at x and denoted by f dash of x. So limit should exist here. Okay. This f dash of x can also be written as d by dx of f of x. Okay, that is we are differentiating with respect to x. So what do you mean by differentiation? It is a process of finding out the derivative. Okay. So we'll see some examples. F of x equal to 2x. Okay. So we will be finding derivative using first principle. So first you write down f of x plus h. So wherever x is there, you have to write x plus h. Okay, so this becomes our 2x plus 2h. Okay. Now we'll write the formula. Limit is h tends to 0 f of x plus h minus f of x upon h. F of x plus h is 2x plus 2h minus 2x upon h. So this is 2h upon h, right? So h also gets cancelled. So you will get the answer as 2. Okay. Solve another one. So x square. So f of x plus h is x plus h the whole square. Okay. So using a plus b the whole square formula, limit as f dash of x equal to h tends to 0 f of x plus h, I'll directly write it here, minus f of x upon h. So you can take common h. Substituting h equal to 0, we'll get answer as 2x. Okay. Let's write it for e raised to x. So f of x plus h is e raised to x plus h. Okay. F dash of x is limit as h tends to 0, e raised to x plus h minus e raised to x upon h. We'll take e raised to x common. So inside it is e raised to h minus 1 upon h. So as h tends to 0, this thing becomes log e, which is 1. So the final answer is e raised to x. Okay, so derivative of e raised to x remains same, that is e raised to x. E raised to x. Same way you have to solve. Minus 1h common. Okay, this becomes log a. So a raised to x log a. This is the derivative. Let's find out for log x. So this is log a minus log b. So log of a upon b you can write upon x. Okay. So this becomes x upon x plus h upon x. Correct? So x upon x, I'll write it here. So this gets cancelled. So you'll get 1 plus 1 upon x into h. Okay. This is of that last form. Okay. That standard result. Log of 1 plus kx upon x. So the answer was k. Correct? Here our k is 1 by x. So as h tends to 0, we have 1 by x is the answer. Okay, this is the derivative. Next we'll see sin of x. X plus h is sin of x plus h. So here it is given sin a minus sin b. So that formula you have to use. Trigonometry, from trigonometry. That is 2 cos a plus b upon 2 into sin a minus b upon 2 divided by h. Okay. So this becomes 2 times cos 2x plus h upon 2 sin h by 2 divided by 2 divided by h, sorry. Okay, so here we can do one thing, that is we have h tending to 0, right? So if I take here h tending to 0, this will become cos of x directly, because h is 0, so 2 and 2 will get cancelled. Here we have to use the trigonometric limit sin of x upon x. So we have to make this as h by 2. So I'll divide and multiply by 2. So this whole thing as h tends to 0 becomes 1. Okay. This 2 gets cancelled with this 2. So we'll get here cos 2x upon 2 because h is 0. So the final answer is cos of x. So the derivative of sin of x is cos of x.